Welcome to the stream. My name is Eric. I am just another coding guy. Just a coding guy. And today we're going to continue where we left off on codefights.com. Arcade mode, trying to get through some of the easier problems, not so easy problems. We're in the second, what do you call this? Section? I guess these are sections, areas, levels. I'm not really sure, but we're almost finished. I hope to finish this tonight. Some of these are really easy. Some of these are more challenging. So let's go back to where we were on this one. So given a sequence of integers, so I gave this one some thought. I was trying really hard to go through this one time, like to be able to. My biggest problem with this was trying to do the solution and finish it in one pass over the input sequence, and that was challenging for a number of reasons. Some corner cases that were really strange. Swapping elements would then make a new case, which we already passed over. It just wasn't working out. So I decided, you know what? I'm just gonna pass through it. I'm just gonna pass over it twice. Who cares? You know, I'll pass over it 2 times, and if I can pass through it once and do my swaps and I have to remove one, then great. If I can go through a second one and I have to remove one, then I know I can't do it with only removing one. That's the whole premise of the problem, is that you can obtain a strictly increasing sequence by removing no more than one element from the array. So that means all we have to do is pass through the array once. If we have to remove an element, we remove it. Then we pass through it a second time, and the same thing. If we have to remove an element, we remove it. So let's give that a shot. So what did I do here? Let me get my problem, my practice array up here. I want to do this fast because I just want to get out of this problem. I don't like this problem. It's boring now. I've done it too many times. I've looked through it too many times. So strictly increasing. That means I look through at n and n plus 1. Let's see. Index equals 0. I'm just going to do it that way. You know what? Let's just do this. Let's do a for loop. Who cares about this other stuff? For int I equals 0, I is less than sequence dot size minus 1. We do this, remember we do the sequence minus, typically when you do a for loop, when you want to iterate through every element in the loop, you go through to I is less than sequence.size. But since we actually are looking at this element and then the element plus 1, we want to make sure we stop before the last element so that we don't get out of bounds. Get an exception, throw an exception there. So we do minus 1 there. Plus I. Let's see. If let's see. If sequence, sorry, I was losing my train of thought. Sequence of I is less than sequences I is greater than or equal to sequence of I plus 1. We'll put this statement in there. That's our shortcut or our short circuit statement. If removed 1 already, then we would just return false. We can't do it, period. In fact, we don't even need to... We need to remove 1. We do need to actually remove it to check. Sequence.erase. Since I was just playing around with this, but what we're going to do is... Not a big fan of C++ and this particular feature. The iterators. Not a huge fan. I couldn't just use the index here. The erase, sequence.erase uses the STL iterators. Just another way of accessing parts of the different sections of the vector. I don't know. I don't like it. It's not intuitive to me, I guess. Using numbers is more intuitive. Anyways. Sequence.erase, we erase plus 1 plus I. Because the I is the, not the, yeah. And then moved 1 equals true. And then you know what we're going to do? Because I'm lazy. Dang it. Now I got to change this. Change this to J. Oop. J. There's a typo here. It's supposed to be 1. JJ. And then my outer loop will be int I equals 0. I is less than 2. I plus plus. So I want to do it twice. Why? Because it doesn't actually affect our doesn't affect our big O at all, actually, that we're iterating twice. Because iterating over the vector once would be an n. Iterating over it twice is 2n. But for big O, it doesn't matter that it's 2n. You drop the constants. You drop the coefficients. And that's what your big O is, so. So there probably is a way to do it without... Man, I jacked all this up. There probably is a way to do this without... with only going through it once. But I'm too lazy to find it. Does this work? I don't know. I'm just going to run the tests. If it doesn't work, then we'll run it on paper. By paper, I mean using Atom, a good old text editor. So a lot more tests passed than before. Makes me happy. But there's still some that don't work for us. Let's do with test 10. What's going on? Sequence 101. It just completely breaks. Doesn't like it. So what's going on here? Let's run it on paper using this. So, well, we don't need this. Take that out. So we'll do removed 1, removed equals false. And we start here. So for int I, so I equals 0, and then we step into the loop, j equals 0, j is less than sequence.size minus 1, j plus plus. Oh, you know what? That's one problem. I forgot. If we make it out, guys, we have to return true. Maybe that was the problem. Yeah, it might have been it. Because fun, it was a really sad day when I learned this, but not having a return statement in C++ is only a compiler warning. It's not an error. So, sad but true. So, today you learned something. Anyway, so return true. Let me see if that fixes it. Before I run this on paper, I'm going to just take a stab at it. It fixed one test. Okay, so it did fix this test. That's good. That makes me happy. I'm scared for all these other tests, though. There's only like... Oh, there's 2 tests that failed. Oops. I wonder if it failed for the same reason, though. I don't know. Let's find out. Let's just do this one. Alright, so we have... Let me take this out. 1, 2, 3, 4, 3, 6. Wait, do I have output here? Sorry, I was just thinking about that. Like, I would like to see if I had some output. Oh well. Anyways, so I is 0, f removed as f, I is equal to 0, j is equal to 0. So now, if sequence of j, which is 0, is greater than or equal to sequence of j plus 1, 0 plus 1 is 1, right here, is it greater than or equal to? It is not. So we skip out of this statement here, and then we start here again. We iterate, or we increment j, and so now j is 1. So now, if sequence of j, so that would be this one, is greater than or equal to sequence of j plus 1, so j plus 1 is 2, 0, 1, 2, is 2 greater than or equal to 3? It is not. So we skip out of it. We go to the for loop, up here, j plus plus, plus plus j, same thing in this case, 2. So now we go, if sequence of j, which is 0, 1, 2, is greater than or equal to sequence of j plus 1, j is 2, so 3, 0, 1, 2, 3, is 3 greater than or equal to 4? It is not. So we skip out of this if block and iterate again, j plus plus. Now let's check, make sure we're still in index here. Is j less than or less than sequence dot size 0, 1, or 1, 2, 3, 4, 5, 6 minus 1 is 5. Let's put 5 there. I mean, yeah, 5 because it's minus 1. So is 3 less than 5? It is. So we're going to keep going. If sequence of j, 0, 1, 2, 3 is greater than or equal to sequence of j plus 1, so that's 4, 0, 1, 2, 3, 4, is 4 greater than or equal to 3? It is. So now, If removed one is true, return false. But right now it's false, so we don't do anything. We skip out of that block. Sequence.erase, sequence.begin plus j. So we go here. 1 plus 2 plus 3. And we remove it. Like that. Good. Okay, sorry. And that actually changes our size minus 1. So 1, 2, 3, 4, 5 minus 1 is 4. 4, great. Remove 1 now equals true, by the way. So now, for int so what does that mean now? We keep going. Yes. J is 3. Is j plus j, yes. 4. So is j now less than size minus 1? It is not. So now we jump out of this loop. We loop on here. I is now 1. J is back to 0. Or it's not even in scope right now, I don't think. Is I less than 2? It is. So now we keep going. Int j equals 0. J less than sequence size minus 1 is true. If sequence of j, which is here, is greater than or equal to j plus 1, is 1 greater than or equal to 2? It's not. So we skip out. So this check fails. Skip. Here again, j plus plus. Hello viewer, good to see you. So j plus plus. Now we go here again. Is j less than sequence size minus 1? So that means it's 1 less than or 4. It is. So we continue into the for loop. Sequence of j 0, 1 is 2. Greater than or equal to sequence of j plus 1. So that'd be 0, 1, 2. Is 2 greater than or equal to 3? It is not. So we skip out. Boom, boom. J plus plus. We're still in bounds here. So we're gonna keep going. Is sequence of j 0, 1, 2, 3 greater than or equal to sequence of j plus 1? So 2, 0, 1, 2, 3. Looking at these two elements. So is 3 greater than or equal to 3? It is. So we actually go into the block. If removed 1 is true, which it is, return false. So we should return false. And that should be what we return. What did the test expect? The output was false, which is what we had. It expects true, though. Expects true. I don't know why it would do that. What we might have to do is print out sequence dot 1, 2, 3, 4. Oh, I see the problem. If we had simply removed 3, then we would have been fine. But instead we removed. Maybe we should be removing the one ahead of it. How would that work? So right now what I'm doing is I'm looking ahead. What's the original test here? 1, 2, 3, 4, 3, 6. 1, 2, 3, 4, 3, 6, right? So 1, 2, 3, 4, 6. Right now when I'm looking in this window, I say, oh look, I have this greater element, and I have this lesser element. I'm going to go ahead and remove the greater one, But really, maybe that's not the best way to do it, because this is true. This is an increasing sequence. But this is not an increasing sequence, and it's not 4's fault. It's really 3's fault for being behind. So why am I removing the one that's the first one that was greater? Really, I should probably be removing this one that's not strictly increasing. So maybe I'll do that instead. And how will I do that? I will remove the other one. So this means instead of erasing the 1 plus j, it'll be j here plus 1. So let's see if that works. Let's see if jumping ahead works, and I will run these tests. It's actually more tests that fail now. See, now here's the opposite is true, where if I had just removed the first one, then I would have been okay. Right now, I'm trying to think if I had. So I have two conflicting cases or ideas. Like I could remove the first one or remove the second one, and there's always there's going to be a case that defeats it either way. I could check both. Right? What if I... Yeah, why not? I'll just check both. So what I'm going to do is sequence J I don't know if that'll work or not, but sequence of J is 10 Man, I don't like this problem. I might have to buy a hint. How much does a hint cost? I want to buy a hint. How much? Oh, okay. Great, I had to pick the obfuscated one. What if I put it in a linked list? A circular linked list. That would be interesting. If I have a different... strictly increasing sequence. What if I did it in a strictly increasing sequence, then I did it backwards once? I'm already doing it twice. Well, maybe somebody will come in here and help me. I'm trying to think right now of whether or not I go backwards once, go forwards once. So, what case failed? It was this case right here. The cases that have... Two, 5, 3, 5. Really, I'm looking at this as like complex logic, right? I check here and I check here. 499. I say, yeah, well, remove 99. Well, don't remove it, it's increasing, so don't remove it. But then I realize that it's not strictly increasing. Because I say, oh, well, this isn't good. Could I swap it? Would that help? Hmm. I don't know. I'm having a hard time with this one, guys. That other hint didn't really help me, unfortunately. Let me look at this hint again. Fine, we're just going to copy this code. As much as I hate doing this, but I'm going to do it. So we just have to fill in the question marks now at this point. Int n equals a.size, p is probably equal to -1, c equals 0. For int I equals 1, I less than, and blah blah. So for int n equals a.size, guessing he means sequence. Oh, he minned his code. Fine, a, make him happy. So for int n equals a.size, so we'll say this. N equals 4. P equals -1. C equals 0. For I equals 1, I less than n, I plus plus. I equals 1. If a of I minus 1 is greater than or equal to a of I, P equals I. So a of I minus 1, yes, is greater than or equal to a of I here. Is it greater than or equal to? It is not. So I equals 2. If a of I 0, 1, 2 is greater than or equal to, wait, if a of I minus 1 is greater than or equal to blah blah blah. If a of I minus 1, 0, 1, 2, minus 1 is greater than or equal to a of I, which it is, then P equals I, C++. C++, get it? That's funny. If C is greater than that, let's do. Stab in the dark here, guys. Filling in the blanks. Didn't even compile. Look at that. I'm excited. I'm just going to submit it so I can be done with this. That's all I really want to do is be done. Oh, thank goodness. Finally, I finished this. Cost me coins, but I did it. Matrix Elements Sum. After they became famous, the Codebots all decided to move to a new building and live together. The building is represented by a rectangular matrix of rooms. Each cell in the matrix contains an integer that represents the price of the room. Some rooms are free, their cost is 0. That's probably because they are haunted, so all the bots are afraid of them. That is why any room that is free or is located anywhere below a free room in the same column is not considered suitable for the bots to live in. Okay, so I like this. I like this problem. It sounds like fun. Let's get the matrix in here. So basically, we got to figure out which rooms are suitable, which rooms are not suitable. Right. So what I'm thinking is you have so 1, 1, 2, 5. You have rooms that are suitable, and rooms that are not suitable. We're concerned with the columns and the rooms themselves. So I'm thinking a vector of bool is going to be necessary. And basically what I'm going to do is valid column. And I'll keep one bool for each column, and when I encounter a room that's unsuitable, then we will say that we mark the whole column as invalid at that point. So let's do this. And then all initialize a true, true, and true. So we're going to have two loops, really. We're going to have in I and j. I equals 0. J equals 0. As we go through, so this will be anyways, okay. we start off looking at 0, 0, right? This room is haunted. So we're looking at if matrix of I j is equal to 0, then and does j iterate on really needs to be, yeah, so then is valid column of j equals false. Also, we need to check if is valid column of j equal false. I like to use equal false here instead of just saying like not or putting the negation symbol here like this. I prefer to just say equals false. It's easier to read. So really, that's what you want to do with source code. You want to rate it. You want to you're writing source code to tell people how to tell the computer what to do, not just tell the computer what to do. I think that's a quote by somebody important and famous, and I can't remember who it is now. Sorry. Anyways, so if it's false, then continue. If the matrix at that is 0, then is valid column F, else total plus equals that should work. Alright. I'm comfortable with that. I think we're going to give that a shot. So we have int total equals 0. Bool is valid column why do I always do this? Initialize one day I'll remember this. Yeah, how do you initialize an array with... Yeah, is that not how you do it? to default value. Oh, phooey. I'm just gonna do is valid column matrix of 0 dot size. Don't even know if you could do that because this is not constant. This is a runtime defined thing. Can you do that? I'm just gonna compile it. Okay, well, at least it compiles. I'll just initialize it with a loop. For int I equals 0, I is less than matrix 0 dot size plus I. Column I equals true, because they're all valid at first. So make sure we initialize it all valid. Cool. Now we also have total, that's good. So now for int I equals 0, I is less than matrix dot size plus I plus I, and then another for loop, right? For int j equals 0, j is less than matrix of 0 dot size plus j. Continue. I think this code will just paste right in there. Right? Okay, man, get over there. Boom. Boom, boom, boom. Return total. Run the tests. Compile error. No compile error. It just works. Amazing. Look how many test cases there are in this case. There's only a couple. The other one was tons. So maybe I get lucky. Maybe it just works. And does it work? Boom! Look at that, guys. Some are easier than others, it seems. The other one was really hard. Anyways. Oh, did I complete? Yes, look at that. 4,000 plus. Good to see. Look at that. So I finally finished the first two sections, I guess. And now I'm gonna move on to this next one. Anyways, but now it's 8:30, so I'm gonna take a break. It was good coding with you guys. If you have any questions, please let me know. Like I said, I'm not the best programmer, but I know some stuff. I know a couple of things. So please don't hesitate to ask. Thanks y'all for watching. Again, my name is Eric, and I'm just a coding guy. See you again next time. Thank you.